Hi, my name is Claudia Cohen and I'm currently taking CSE 2. So in this video, I'm going to explain how the fall 2013 final exam question number 1 is done. So basically, the different aspects of the Java language that this question focuses on include applying the Unix commands, make sure that you're doing explicit casting, and even some work with variable declaration and keeping track of your variables. A common misconception that a lot of people experience while trying to solve this problem is not going line by line. And if you don't go line by line, you're going to definitely trip yourself up and you will lose the variables that you are really looking for to solve. So one of the couple of ways that I prepared for this question on the final exam was by doing homework number 3 that talks about a pyramid and different lengths and importing numbers and variables. And it was great practice for this question on the exam. So part 1 of number 1 question listed on this exam is to write a sequence of 4 Unix commands that are going to perform the following. So we know we're going to have a list of commands that are going to do all of these different activities. So the best way that I was able to understand these is by looking at Professor Chen's PowerPoint lecture number 2. So basically he describes what an operating system is, which is the software that takes care of all of the background work in the computer hardware so you can use it. And it's run, and the operating system that we're going to be using is Unix. We're going to use the terminal to be able to type in these Unix commands to be able to make sure our computer's running. And we can just start off with the most important command, which is man. And man stands for manual, and it says what any other command does and how to use it. And we just are going to have to memorize all of these ones. So the first command you need to know is ls. And ls stands for list, and it's really easy to just type in ls whatever directory you're looking at the moment, and it's going to list located in the directory that you're looking at. We also need to know the command cd because it's going to say change directory, so you're going to move yourself away from one directory and you're going to change directory to go to a different directory. So pwd command reports the full path to the current directory. And now when we look at these directories, we know that there are different levels of folders so that it's easy to navigate between going to the different levels. So also shortcuts to keep in mind about directories are that the NA / is the shortcut for your home directory. Period / is the shortcut for the directory above the current directory. Periods / is the shortcut for the current directory, and / is the base directory. You cannot above it. So here is basically a more intense description of the directories and paths. So every time you move to another level of the directory and move down, you're going to add another / and then the name of the directory that you're looking for. Other commands include copying and moving files. Moving kind of reminds me a little bit of cut because it's going to delete the original source file and move it to a destination. And you have to be really careful when making and deleting directories. Making's fine, but mkdir makes a new directory and rmdir removes an empty directory, and rm-r removes a non-empty directory and literally everything inside of the directory, so you have to be really careful when you're using that so you don't delete all of your files. Okay, so one way that I used charts to compile all the Unix commands is to do, so the first part of the problem that we're going to solve is we're going to change the working directory to your home directory. So change the working directory is cd, and the shortcut for our home directory is the NA. And don't forget a semicolon after each one of those. Also, I'm sorry that I'm using PowerPoint. There should not be a capital letter in the front of any of these commands. in order to create a subdirectory of your home directory called final exam, we're creating, so we're going to do mkdir, and because it's going to be called final_exam, we're going to type in final_exam, semicolon. Then, to copy a file into your home directory called study guide into the final exam subdirectory that we just created, we're going to copy, CP, remember, study guide, and then final_exam, semicolon. Next, in order to display the contents of the final exam subdirectory, we would use the list function. There's the list, and then final_exam. Very simple. Very simple. So for the part 2 of this question, what we're going to do is what is the final value of x after each snippet of code? If x is undefined, write undefined. So we're going to use Professor Chen's lecture number 4 in order to help us solve this problem. So one concept that's crucial in this problem that you're about to see in about 10 seconds is to know that explicit casting is used when you need to take one variable and turn it into another. So it's really difficult to do it without seeing it. So we are going to take, so for example, if you have my double value is this number. In order to cast this double into an int, you're going to create it into my int, and you're going to take the variable listed here on the other side, and you're going to put int in parentheses in front of it. This turns this variable 3.141592 into just 3, because you just tail off the decimal part of a double when it becomes an int. So basically we need to follow the steps to evaluate this. So basically D1 is divided by D2, which is going to be 3.2 divided by 4.5, and then whatever this total is going to be turned into an integer, and then D3 is divided by D4, and whatever result that is, that's going to be turned into an integer, and then basically we are going to the division needs to be done as integers, and after dividing these two by one another, becomes an integer. So, and because it becomes a truncate decimal, which is basically what we said about the tailing off, that this decimal is going to get tailed off at the end of the problem. So basically, the way that it's really important to know about the swapping variables, because each time that your variable becomes something else, it's redefined, which it's very complicated to kind of look at this example and sort of see that that basically if my val is originally equal to 3 and then my val is 2 is originally equal to 4, the minute my val becomes my val is equal to 2, my val 1 is no longer 3, it actually becomes 4. And then my val 2 it starts off as 4, and then the minute it's equal to my val 1, it's going to be my val 2 is going to be equal to 3. Okay, so now I promise you it's going to be easier to understand when you go through these different snippets of examples. So basically, we're going to start off with snippet 1, and we start off with saying that int x is equal to 2, and then int y is equal to 7 times x. So, after going through this first line, we realize that for y, the new definition of y is actually going to be 14, because we're going to do 7 times 2 equals 14. Then we go to the next line that tells us that x is now equal to x times y. So this new value of y, which is 14, is now going to be multiplied by the value of x, which is 2. So x is now equal to 28. And then y is equal to 28 as well. So x is equal to 28. and y is equal to 28, which means that our answer is, because we're trying to say what x is equal to, is x is equal to 28. For all of these ones, we need to solve and figure out what x is equal to. So, for the next one, we're going to go line by line again, and double w is equal to 1.5, double x is equal to 3, double y is equal to 4.8, and the first line is w equals x plus y, and we get w equals 3.8 plus 4.8, which is 7.8, and then x is equal to y divided by z. Now, immediately we realize that z has not been defined as a double. And because z has not been defined as a double, it will not work. It's undefined because we can never find out what x is because z is not even a variable defined. So, snippet 3, we start off that integer x is equal to 2, double y is equal to 3.4, and then we take y becomes equal to y times x. So we plug it in as y now becomes 3.4 times 2, which is 6.8. And then the next one, we have x has now become equal to x plus that, remember our casting rule, integer y. So basically when we're casting a double to an integer, we need to tail off the 0.8 and it becomes 6. So x is equal to 2 plus 6, which is equal to 8. Therefore, x is equal to 8. Last one, we get to use strings for it. So for the first, we have our strings defined as string w equals the, x is equal to quick, string y is equal to white, string z is equal to rabbit. So we start off with y is equal to y, which is white, plus a space, and rabbit, which is z, and y. So therefore y equals white rabbit for now. So then the w equals the w, which is the, then space, and then because y has now become white rabbit, we have the white rabbit for w. Then for x, because we have x is equal to w, which we redefined here as the white rabbit, and then plus x, which is quick. So we have the white rabbit quick as our value for x.